All right, today we're going to pull back the curtain on the secret language that powers just about everything in our digital world. We're talking about the engine behind AI, machine learning, and data science itself. Yep, we're talking about statistics.
You ever just stop and think about that for a second? Or how your favorite streaming service just knows what you want to watch next? It honestly feels like magic, right? But it's not. It's something way more interesting at work. A system that's making these incredibly smart guesses based on what's happened before.
And that's exactly what we're diving into. The secret sauce is statistics. It gives us the rules, the framework, the actual grammar we need to make sense of the mountains of data all around us. It's how we get data to tell us its story.
So, here's the plan. First, we'll cover the why and what of stats. Then, we'll get into how to actually tell a story with data. After that, we'll tackle the rules of chance, see how to make really smart predictions, and finally, wrap up with how data scientists put their big ideas to the test. Sound good? Let's get into it.
Okay, first things first. What even is statistics, and why is it so absolutely critical in the world of data today? At its core, you can really think of statistics as a four-step process. It's not just about crunching numbers. It's a whole method for grabbing raw info, making sense of it, figuring out what it all means, and then, this is key, telling others what you found in a way they can actually understand. And really, statistics breaks down into two main jobs. On one hand, you've got descriptive statistics. This is all about summarizing the data you've got right in front of you. Just describing the scene. On the other hand, you have inferential statistics. And this is where the magic happens. It's where you take a small piece of data and make a smart guess, an inference, about a much, much bigger group.
This whole toolkit is the absolute bedrock of data science. You use it to explore your data, make better decisions, build those predictive models like the one on your phone, and even figure out how risky or uncertain something is. Seriously, every single machine learning model out there stands on the shoulders of these ideas.
All right, so let's put on our detective hats and get into that first part, descriptive statistics. Think about it. When the detective shows up at a scene, what's the first thing they do? They summarize the evidence, and that's exactly what we're about to do with our data.
So, to make this real, we're going to use this super simple data set, just 9 test scores from a group of students. Now, don't get hung up on all the math on the screen. We're going to walk through the big ideas one by one. For now, just think of these 9 numbers as the clues we've collected.
Now, the very first question a data detective asks is, so what's a typical value here? And we've got 3 main tools to find the center of our data. There's the mean, which is just the good old average. There's the median, which is the number smack dab in the middle. And the mode, which is simply the number that shows up the most often.
For our student scores, if you add them all up and divide by 9, you get a mean of 79.77. You can think of this number as the center of gravity for all the scores.
Now, if you line up all 9 scores from smallest to largest, the one right in the middle, the 5th one, is 78. That's our median. And what's cool about the median is that it doesn't really care about super high or super low scores, which can sometimes throw off the mean.
But knowing the center is only half the story. We also need to know about the spread. Are all the scores huddled together around the average, or are they all over the map? That's where standard deviation comes in. For our scores, it's 8.24. That tells us that a typical score is about 8 points away from that average of 79. A big number here would mean the scores are inconsistent. A small one means they're pretty predictable.
So we're getting pretty good at describing what's already happened. But how in the world do we start predicting what might happen next? Well, for that, we have to learn the rules of the game. We need to speak the language of chance, and that is probability.
Probability is really just a number from 0 to 1 that tells you how likely something is. The easiest example is rolling a die. You've got 6 possible outcomes, right? So what's the chance you roll a 4? Well, there's only 1 4 on the die, so that's 1 favorable outcome out of 6 total outcomes. Your probability is 1/6. Simple as that.
Okay, now for the really cool part. Let's put everything together. We can use this idea of probability to take what we learn from a small group and make that huge leap, drawing conclusions about a giant population. This is the heart and soul of inferential statistics.
The whole game here revolves around the idea of a population versus a sample. The population is everyone we care about, like, say, every single voter in a country. You can't talk to all of them. It's impossible. So instead, you talk to a sample, a small but representative slice of that whole group.
And I absolutely love this analogy. Just think of a giant pot of soup. That's your population.
You don't have to eat the entire pot to know if you made it right. You just take one spoonful, that's your sample, and you get a pretty darn good idea of what the whole pot tastes like. That, right there, is the big idea of sampling.
So you've tasted the spoonful of soup, and you have a theory about the whole pot. But how sure are you? Well, now it's time to put that theory on trial and see if the evidence holds up. This is what we call hypothesis testing.
And in this data courtroom, there are always two competing stories. The first is the null hypothesis. This is the boring status quo idea that nothing interesting is going on. Think, this new drug does nothing. Then you have the alternative hypothesis. This is your new, exciting theory. Hey, this drug actually works. As the data scientist, your job is to be the prosecutor and find enough evidence to convince the jury to reject that boring old null hypothesis.
And to find that evidence, we use tools like this t-test. Again, don't get lost in the formula. All you need to know is that this math does one job. It takes all of our evidence from our sample and boils it down into a single number, a t-value. This one number tells us how weird or surprising our result is, if that old boring theory was actually true.
And here's the bottom line. If that t-value we calculate is extreme enough, if it's so weird that it's super unlikely to have happened just by random luck, then we've got our verdict. We can confidently stand up and say, we reject the null hypothesis. The evidence is too strong to ignore our new idea.
And that's our journey in a nutshell. We've seen that statistics is this amazing two-part toolkit. We learned how to describe any data by finding its center and its spread. We saw the magic of using a tiny sample to understand a huge population. And finally, we saw how to put our ideas on trial with hypothesis testing to prove we're onto something real.
So, you now have the basic grammar, the fundamental building blocks for understanding the world through data. The only real question left is, what stories are you going to tell? What problems will you solve? The data is out there, and now it's waiting for you